Hello, everyone. Hello, Seattle. And I'm Jason Mays, WebAI lead at Google for the teams that focus on the art of running client-side machine learning models in a web browser. Now, you might be wondering, why should we be caring about WebAI? Surely you can do all of this on the cloud, right? Well, you can get some superpowers that are just not possible with a cloud alternative. Now, I know we're all from different industries, so think about how any of these could apply to yours as we go through them. First up is privacy, as no data from things like the camera, microphone, or even text need to be sent to some remote AI model on a server, which protects the user's personal data. A great example of this is shown here by Include Health, who use browser-based pose estimation models to perform remote physiotherapy without sending any imagery to the cloud. Instead, only the resulting range of motion and statistics from the session are sent, allowing the patient to perform their checkup from the comfort of their own home while also protecting their privacy. You've also got the ability to run offline on the device itself, so you can even perform tasks in areas of low or no connectivity after the page load. Now, you might be wondering, why would you need a web app to work offline? Well, in this great example by Hugo Zanini, he performs product placement verification using a web app in supermarkets for a retail customer that he was working with. And we all know how bad data connections are in large metal structures like supermarkets. He leveraged tensorflow.js to run a custom object detection model right in the browser that can work entirely offline and then syncs data back when a connection is available later on. You can imagine applying similar techniques to retail analytics solutions to monitor what objects are most interacted with, or understand how busy an area is at different times of a day. Or what about healthcare solutions in pharmacies to count pills more effectively, and much, much more, all working offline to conform with regulations? Next is low latency, which can enable you to run many models in real time, as you don't have to wait for the data to be sent to the cloud and back again, which might be significant if you're on a mobile phone data connection, for example. As such, many of our models, like these ones from MediaPipe, for body pose and segmentation, can run over 120 frames per second on a mid-range laptop's graphics card, with great accuracy, as you can see on this slide. And you've also got lower cost, as you don't need to hire and keep running expensive cloud-based graphics cards and processors, which means you can now run generative AI directly in the web browser, like this large language model on the left, without breaking the bank. And we're now seeing production-ready web apps benefit from significant cost savings, like the example shown on the right for advanced video conferencing features, such as background blurring right in the browser. And even better, you can offer a frictionless experience for your end users, as no install is required to run a web page. Just go to a link, and it just works. In fact, Adobe did exactly that here with Adobe Photoshop Web, enabling anyone, anywhere, to use their favorite creative features on almost any device. When it comes to the object selection tool shown on this slide, embracing client-side machine learning for this feature can provide Adobe's users with a better user experience by eliminating that cloud server latency, resulting in faster predictions and a more responsive user interface. And on that note, of course, you can leverage the reach and scale of the web itself, that has around 6 billion browser-enabled devices capable of viewing your creation. OK, so now let's head on over to see what the WebAI community have been up to over the last few years. These are people just like you, but are already using machine learning in JavaScript in their products and services to give you a taste of what's already been possible to bring you up to speed.
Fundamentally, what we're trying to do is build tools to allow anybody to be their true self. There's a lot of people that feel uncomfortable on camera. Here's like a much more detailed side-by-side view of my face being captured alongside the face of the 3D character. And so what's happening is it's tracking individual facial blend shapes and then relaying them back into that Unreal Engine to render them.
I work as a radiologist, and the last 4 years I've been really interested in using artificial intelligence for segmentation. And this is a really nice thing with TensorFlow.js, I think, is that you can interact with the AI models. It doesn't have to do fully automatic predictions, but you can actually kind of guide the models to get the result that you want.
We're going to see an animatronic talking backpack that uses face mesh, and it was sort of a comedian in the wild experiment that respected social distancing. It does what you see. It puts all these tracking points on a face, and it can track it with and without glasses. It has an incredibly high frame rate, even in JavaScript and even in browser. So wouldn't it be great if you could use this technology to control animatronics?
So this is an example of how Cardinal Health is using RoboFlow to improve the backrooms of pharmacies. So they have a division of their company that works with pharmacists where one pharmacist can manage several locations remotely over a video stream. And so this runs in the browser on an iPad, and previously it was just a video chat between the pharmacist and the technician. And then they used RoboFlow to add on a pill counting feature that helps the pharmacists be augmented by the computer vision model so that they don't have to count from scratch. They can use the model to estimate and then adjust up and down where the model has not gotten an exact count.
The video that I'd love to show here is a video piece that I constructed, which I call Mirror Exercise. And this is an AI-generated duet with myself. So what you're seeing here is in the figure in black is my real motion capture data from a couple data taking sessions in the studio. And in blue, you see a dancing accompaniment that is generated by the model. So in each case, the model is seeing a certain segment of my movements and is creating a slight variation on it in some sense.
It's a hand tracking engine called Yoha, and so what it does is it processes the video feed of your webcam, and it detects the location of your hand in this video feed. And the goal of it is that it allows you to quickly sketch something roughly similar to how you would do it on a whiteboard.
Himo is a visual workflow engine that allows you to build very complex solutions in just minutes. And we do that through a drag and drop interface, which helps you define any kind of process without the need for coding. So this is the final version of the program. The video is a bit sped up, so things happen fast, but you can see that as water is taken out from the container, the graph reflects the changes in the level of the liquid, which is what we wanted.
We wanted to go beyond machine and even beyond the clinic. And so that's really when we decided to expand our platform into computer vision and delivering care directly into patients' homes on their own devices. We're a medical device that we can run on any device, fully web-based. And you can see these patients doing different exercises, upper body, lower body, with real-time feedback, counting their reps. We track their range of motion. We gather all that and send it back to the clinician for review to help modify their home exercise plans accordingly.
All right, so some pretty cool demos there, right? But today, I've come to share a story about the future of the internet itself and why all of you should start investigating agentic behaviors on device, within the browser, in JavaScript, to gain extraordinary abilities for your existing web applications as users' devices continue to get more powerful. In 2024, the WebAI community progressed towards a smarter web that enabled you to do more things than ever before, like this prototype that enabled videos to literally watch themselves for you, extracting useful video frames in real time to grab moments that matter automatically and could even work offline. In this video, you can see I asked it to find frames with the words Jason Mays contained within them, or a person standing on a plane, which is one of my hobbies when I'm not nerding out on WebAI. And sure enough, it extracts them along the bottom for me, entirely client-side, no server calls needed. But this, while smart, is not an agentic behavior. So what's an agent? At its essence, an agent is a system that can perform advanced tasks autonomously on behalf of the user by breaking them down into structured steps that can then be used to complete the task without user intervention. An agent can dynamically select and use exposed tools potentially many times in a loop, allowing it to interact with the outside world, filling in any missing knowledge it may need, or perform an external action to then complete each substep beyond the constraints of the core language model that is ultimately driving the agent's internal thinking and logic. So let's dive into that tools concept a bit deeper. While language models contain a vast amount of knowledge of the world, if you ask one what the weather is today in London, it will likely hallucinate an answer that might be wrong. Instead, you can expose a tool that fetches the current weather for a given city, and the language model can choose to call that with the inputs it needs to get up-to-date information about the weather, and then use that response in its own contextual history to perform the task correctly. Now, tools allow the language model to bridge the gap between itself and the outside world. An agent can potentially use many of them to interact with various external data and services, unlocking more powerful actions that could be used to help it solve the goals set. The example shown here illustrates potential tools you might expose for a holiday planning agent. And common types of tools include calling a function to perform some task, or taking an action via an extension via an API, or fetching relevant contextual information from, say, a vector data store. Next, with regards language models used, that could actually be one or more LLMs or even multimodal models to understand inputs beyond just text. They are all capable of following instruction-based reasoning. Now, if multiple models are used, the orchestration layer might decide which one to delegate to for the current subtask being performed. But essentially, an agent can plan and define subtasks that it needs to get a job done, and it will choose the appropriate tools in each step, whose output can then be used as extra context in its memory to then reason what it needs to do in future steps in order to complete them without constant human intervention. And they might even choose to cycle through those steps, potentially multiple times, breaking the task down further to eventually complete the task at hand. So, bringing this all together, an agentic system is typically comprised of one or more language models, a memory implementation, and one or more tools it chooses to call. These key subparts are managed and coordinated by the agent runtime, or orchestration layer, if you will, that governs how the agent takes in external inputs, how it should loop to perform the internal reasoning, and even assisting in calling the correct tools that the agent then chooses to use based on structured outputs from the language model itself. Or it can enable an ability to ask follow-up questions to the user as needed, or define valid stopping points to then present the results back to the user. So, how on earth does all this relate to WebAI then? Well, last year I made a prediction that websites of the future may need to be AI agent compatible, such that you could just talk to them naturally to get useful work done faster without needing to learn arbitrary user experiences on different websites. I also predicted that the sites that don't make it easy for agents to work with them may struggle to compete in the agentic AI age, just like how we had to go from desktop to mobile phones in the past when the smartphone was invented. And today, I'm going to demonstrate a WebAI prototype that puts these agentic concepts into action to show you a glimpse of a possible future of the internet itself, whereby websites are designed to work interchangeably with agents and humans alike. I'll be using Google's 2 billion parameter Gemma model, entirely located in a web browser, powered by our MediaPipe Web LLM library, to show you how you can upgrade your existing site with agentic workflows by reusing your existing code exposed as tools that the agent can use in a low-friction manner. Now, I'm also pleased to announce at this point we've also got Gemma 3 models available too, as you can see from the table. And all smaller models up to 12 billion parameters are much faster than reading speed in terms of the tokens per second they produce. And just for fun, we converted a 27 billion parameter model, which can run roughly at reading speed if you've got enough VRAM on your graphics card. Now, while this might not be a mainstream use case, it does show that a 27 billion parameter model is technically possible within WebAI for niche custom solutions, whereby you might want to run such a model maybe for privacy or cost savings reasons. I also want to point out that the free-end models on that table are multimodal, which means you can now use text, audio, and photos as inputs to these models, and then ask questions using natural language about those too, as you can see from the screen captures on the right-hand side. We've basically got a 2 billion or 4 billion effective parameters activated at any time, depending on which model you choose. All right, so if all websites embrace these concepts, we could see a smarter web for everyone. Everything you're about to see is captured in real time on a 5-generation-old NVIDIA 1070 graphics card. So these things are likely to get faster with time, too. Oh, wait for the internet. There we go.
In this demo, we will simulate a flight search page similar to Google Flights to illustrate how this agent could work. Let's go ahead and attempt to book a flight using the AI agent microphone button exposed, but purposely not give enough information. Hey there, I'd like to go on holiday with my friend.
Where are you departing from and when? Is that a one-way trip?
Notice how the agent has already figured out that 2 people are likely going on this trip in the JSON output on the left. However, it also realizes that in order to use the website search tool, it needs more data to call that, so it's asked us a follow-up question too. Let's respond with what it wanted, but also include more data than it asked for to show how it can adapt to anything that the user throws at it. We'll be leaving from San Francisco, but can you pick a popular skiing destination in the French Alps for us to go to? We'll leave on the 5th of December and come back 1 week later.
What is your preferred destination in the French Alps?
I don't mind. You pick a town that's good for skiing in the region. So as you can see, even though I spoke to it quite a bit, it successfully extracted the data information, figured out what 1 week later actually means, and suggested the popular skiing destination of Chamonix, which is a great choice. As it knows that it now has enough information to perform a search, it goes ahead and calls my search tool with the data. Now in this demo, just for fun, I even get the LLM to generate fictional results too, just to show you how much knowledge of the world this tiny 2 billion parameter model has with no tuning. So at no point in this demo did I send any of the data back to the cloud, although in real life, a search would probably end up calling your cloud API to get the latest results from a real flights database. As you can see, it generated some realistic flight options, including some European airlines. All right, now we've got some results. Let's show how versatile this is. You know what? We had a change of plans and an extra friend is coming, and we decided to go to Tokyo instead. As this is a special trip, let's make those seats business class, baby, and change the dates to better dates in autumn. So here, I'm hoping it increments the passenger count to 3, sets seats to business, and destination should become Tokyo. I'm also hoping for some dates in the September to November range, and sure enough, it seems to have worked. Now, as I said, everything here is running entirely locally on my laptop's GPU, meaning that you could talk to it all day long and there'd be no inference costs involved. The only cost here is the initial download of the language model based on its size and the CDN provider that you're using, which is a one-off and it's cached for future page loads.
And of course, speaking of caching, I've created a useful caching proxy library available on the link shown that you can use when fetching large AI models from a server in just a few lines of code. So feel free to reuse this in the code that you write to save yourself some time. Now, this is how easy it is to interact with existing website functions you've already written. And as you've seen, this can lead to an experience that's much more natural for the end user versus having to learn a new user experience for every website they view. Not to mention, even a visually impaired person can now use this interface too, just by talking to the website in a natural manner. Pretty cool, right? But maybe you're wondering how this all comes together. So this diagram shows the key data flow for what I made in the web app that you just saw. The key thing to take note of is that the agent orchestration logic in yellow just attaches to your existing business logic shown in green. And you can choose what functions from your existing web app to expose to provide it with tools to get basically work done faster. On the page load, the web app downloads the large language model I plan to use from cloud storage to power the agentic experience. And once loaded, I can register functions that already exist in the existing business application logic as a tool the agent controller then knows how to use, and call as needed to perform any other task that the website supports. Now let's dive into this part a little bit deeper. In my implementation, the agent is flexibly defined on the side panel as shown on the right there, making it easy to edit on the fly for experimentation. As you can see, I define a persona along with the functions I want to expose as tools just by using regular JS comments that I've already got in my production code base and could be likely auto-generated in the future. And the agent is then aware of their existence to use them as it needs. Now that the core pieces are connected, the WebAI app is ready to go. A user can use their microphone to talk to the configured agent in a natural way using a lightweight speech input layer that I also wrote. And the speech is then transcribed and routed to the agent controller logic shown in yellow, and that uses the loaded LLM along with the agent persona and the exposed tools that are available to use. The LLM has been able to generate a response in a defined structured JSON format that the agent orchestration logic can interpret and deal with, such as asking a follow-up question or calling a tool, until it has enough data to do what's asked of it, in this case, to book a flight. And in my example, a text-to-speech engine is also used to speak back to the user to ask follow-up questions as well. And in case you're wondering how it knew what JSON structure to use, I just specified this in the agent's configuration, whereby I gave an example JSON structured output that I want it to adhere to all the time when speaking to the orchestration layer, so it has a common interface that I know in advance it will use. And finally, when enough information is obtained to perform the desired task, the agent can call the search tool exposed to actually find the flights that match and bring back the results. The key thing to note here is that the results are rendered to the user interface via the existing application logic that you already had in your production site in the non-AI version of your site. So you're just reusing code that you already had in production. Once the results are rendered, the user can make a new request, maybe to apply further filters or change destinations where they desire, kicking off the whole process all over again, except this time it's got a memory, so it doesn't have to ask any follow-up questions. So with that in mind, I can now reuse the same logic with a different web application that has different exposed tools. And in the example shown here, I made a WebAI DJ in just one day by reusing the framework you just saw that now works with public APIs for music services to show how versatile this can be. I've even upgraded the text-to-speech engine to use a WebAI model called Kokoro for a more natural-sounding voice. You can try it for yourself at the link shown, but for now, I've got a preview for in action. If the internet works, 3, 2, 1, there we go, cool.
Play me some music suitable for late-night coding sessions that's chill and not too many words. And sure enough, in this case, it's able to think about its knowledge of the world to pick some artists for the criteria I asked for.
All right, let's get those late-night coding vibes going with some chill tunes. To kick this off, Tycho's dreamy soundscapes are perfect for focusing.
After announcing the track, using the Kokoro WebAI text-to-speech model that's also running entirely locally, it then calls the Spotify API to grab a song for the chosen artist, which it then starts playing immediately. And just like that, in less than a day, I've got a brand new prototype just by changing the tools that it can call and giving it a different persona for how it should behave when talking to the user.
So, as you've seen, WebAI is the art of using machine learning models client-side in a web browser, running on your own device's processor, graphics card, or even NPUs, using JavaScript and surrounding web technologies like WebAssembly, WebGPU, or emerging standards like WebNN for acceleration. And in some cases, the base AI model might even be built into the browser itself and exposed to JavaScript developers via emerging APIs for common tasks like prompting, summarization, and translation. In fact, Chrome is already working on built-in AI APIs running entirely on the user's device too. So that's also a form of WebAI, and you can check their website for more details. Now, all of this is different from Cloud AI, whereby in that case, the model would execute on the server side and be accessed via some sort of API instead, which means you need an active internet connection to talk to the Cloud API at all times to provide those abilities. Right now, generative AI in the browser is in its early stages, but as hardware continues to evolve, we shall continue to see newer, more powerful models being ported to run in the browser on your device, enabling businesses to reimagine what you can actually do on a web page, especially for industry or task-specific situations. In fact, we could see smaller large language models in the 2 to 9 billion parameter range be LoRa-tuned up in the cloud and then run on consumer hardware to provide agentic behaviors like you saw today. And today, we're at the start of a new era, an agentic-powered internet that could really enhance your existing web presence for the services and products you're already providing. And the time is now to start exploring how you can apply WebAI agents to your industry. So consider using hybrid approaches with these smaller local models today. For example, imagine you've got a vector database of domain-specific knowledge up in the cloud. You could pair that as a tool with a WebAI agent on the client side to provide critical context to answer a user's request, allowing you to get more advanced tasks done that otherwise a smaller model couldn't have done by itself. By using both WebAI and Cloud AI together, you get the key benefits of both ecosystems. Now then, I'd just like to end by saying there's very few opportunities in one's life to be at the beginning of a new era like this. I, for one, remember when the internet came out for the very first time. Yes, I am that old. And agentic WebAI has the same feels as that, only magnified 1,000x. I personally believe that in the future, we'll all build AI-compatible websites that expose their available tools in a standardized way, maybe via the new WebMCP standard, whereby you've got an option to just talk to them naturally via text or voice to perform any of the tasks that they support using a client-side AI agent. That way, instead of having to manually figure out some arbitrary workflow or user experience, the agent can use that knowledge to get the job done in seconds. And the browser is one of the best places to do this, as you're already signed in to all the services you love and use daily, enabling you to use the tools from all of those services in one place. So I hope in this talk I've been able to provide you with a tiny glimpse into the future and why you should start investigating WebAI today, because everyone watching here has a chance of a lifetime to shape the future of the industries that you will work in for this fast-growing client-side AI space. And I hope all of you will join me on this adventure. Finally, if you enjoyed this talk and want to learn more, I'm organizing the annual WebAI Summit on Friday, the 17th of October at Google in Sunnyvale, California, to bring 500 curious minds together. You can use the code Cascadia to sign up for a free ticket, but note this is an in-person only event. It's a day full of rapid lightning talks of just 15 minutes each, aimed at maximizing knowledge transfer for client-side AI, and a great place to meet folks to hack with in the future. If you can't make it in person, videos of the talks will go up about a month later, in which case just follow me on LinkedIn and see when those go out. So with that, do tag me in anything you make at your company. You can connect with me on social media or to learn more using the links on the slide. And of course, remember to use the WebAI hashtag for anything you make. And with that, thank you, and see you next time. And let's take a selfie so my manager lets me out the office more often. So thank you. And hands in the air if you can. 3, 2, 1. Way. There we go. Perfect. Thank you very much. Cheers.